this value, HA is equal to 5.784, HD is equal to 2. We substitute into this equation. Okay, we substitute into this. So we will get R is equal to 5.784 minus 2, and this is equal to 3.784 kilonewton. Okay. Now we finish stage number 2. We go to stage number 3. For stage number 3, we will do side sway frame analysis. 3A, we will assume FEM value. This is FEM due to delta prime in this case. So FEM due to delta prime. So in this stage, we have to assume FEM value. FEM due to deflection have to be assumed correctly based on the behavior of the column after side sway. Okay, the idea is, since the column is tend to sway to the right side like this, okay, so it is found that the fixed end moment is acting counterclockwise for both column. Alright, this is AB. Let's say this is AB. Let's say I want to choose AB. Okay, what I need to do is I only choose one column. I assume the FEM for the first column, and then I will determine the remaining FEM for the rest of the column, or the remaining column, the remaining member. Okay. So the assumption here, the assumption that can be made here, and based on the textbook, we assume it as 100 kilonewton meter, and it is the same for both. Alright, so how to determine the direction of FEM like this is due to the behavior of the column due to side sway. Okay, just look at to the angle or the chord rotation between the original position to this is the chord rotation. The angle between original position of the frame, the column. This is original position, which is vertical, and this is the new position. So this angle between the original to the new one is clockwise. So the FEM is counterclockwise. So I can make one conclusion here. So when angle is positive, the FEM is negative. Okay, so that we can push the column to its original position, so we have to apply the negative FEM here. Alright, so from this concept, so we have FEM AB. This is assumption, right? Assumption is equal to FEM BA, since it is fixed, so it is negative 100. and then we apply the formula for both and fixed. Is it equal to 6 E. I for this case is 1000 exponent 6 EI delta prime divided by L is 5 meter. This is equal to negative 100. Okay, and the angle is positive, so we put positive here for the angle. So this is bring to the chord rotation. Okay, alright, so we simplify this and we get E this is exponent, this is E, sorry, so make it clear here. This is the power of 6. Okay, this is E delta prime is equal to negative 100 times 5 divided by 6 times 1000 exponent 6. Okay, so this is E delta prime. We substitute this into the formula of FEM for column CD. Okay, for column CD, so FEM CD, since CD is D is spin, so we use the formula for far and pin, so we have to use 3 E. I is 1250 exponent 6 delta prime, this is divided by 7.5. Alright, it is 3 EI delta prime divided by L squared. Sorry, this is L squared, so this is 5 squared. So this is 5 squared. So this is L squared. Alright. Okay, so we solve this, but before that we have to check the chord rotation, since CD is CD has the same chord rotation, the same angle. It rotates clockwise, so the FEM will rotate counterclockwise, so it is also negative. So the angle here representing by this. So this is referred to the angle positive 3 EI times delta prime divided by 7.5 square. So we want to substitute. Now we substitute E delta prime into this. So we have 3 1250 exponent 6 divided by 7.5 square. Okay, so E delta prime is negative 100 times 5 square divided by 6 times 1000 exponent 6. So we cancel this, Alright, so we solve this, we will get 3 times 1250 times 100 times 5 square divide by 7.5 square divide by 6,000. So we get 27.78. So it is negative 27.78 kilonewton meter. So it is negative because the FEM counter is counterclockwise. So after this, we will repeat the process in 2A. So it is now 3B. So for the next step is M prime. So we put the FEM due to delta from the previous step 3A, and we will find that the M prime as shown: AB, BA, BC, CB, CD, DC. This is M prime. So we get negative 69.91, negative 40.01, 40.01, 23.31, negative 23.31, and 0. Okay, so this is M prime value. So from M prime value, now we go to the next step 3C. We determine R prime. So it is just the repetition with stage 2C. So I will not show the process here, and from the analysis we will get the R value as 12.55 kilonewton, the R prime value. So we already have all the value. So we go to the stage 4. It is M final end moment. It is M naught plus R is 3.78 divided by 12.55 times with M prime. So from this we have the final answer: AB, BA, BC, CB, CD, DC. So this is M final. It is negative 0.948, 13.3, negative 13.3, 18.5, negative 18.5, and DC is 0 since it is pin support. So we have already get the end moment for the side swave frame in example 12.7. So this is all the end moment value, and from this moment we can actually draw the shear force diagram and bending moment diagram as the end of analysis. Okay, that's all. Thank you. Assalamualaikum.